In this problem, there's an airbag that's designed to save lives. We're going to check and see what exactly does it do to help save those lives. So let's assume that you're in a car and you're driving and you're in an accident. So how fast are you going before the accident starts? You're only going 10 meters per second, which is just over 20 miles per hour. So pretty slow. That's about how fast people go in parking lots. Not all that fast. And we're going to say that you get into a collision, and as a result, because you're not wearing your seatbelt, your head is going to have to stop at some point. So it's going to hit something in order to stop. So your head, about 6 kilograms, around 12, 13-pound head, is going to hit one of two things. One is going to hit the steering wheel, which is basically just a steel ring, and it's going to stop in a very short period of time, 0.1 seconds. Or the airbag deploys and your head hits the airbag, in which case your head's going to come to a stop in about half a second. We want to know how much force is being exerted on your head in each one of these situations. So how much does the airbag really do? So we're going to use the impulse momentum theorem, which says the change in momentum is equal to the force multiplied by the time during which that force is exerted on the object, in this case your head. And this little delta just means change in, just a mathematical symbol for change. And how do we find what the change is? Well, the change in momentum is the momentum after. So that's the momentum after your head hits the steering wheel or airbag, minus the momentum before your head hits anything. So before the collision happened. And that's going to be equal to still the force multiplied by the time. Well, we know that once your head hits the steering wheel, it's going to stop. So you're not going to have any momentum after your head hits anything. So we can just put a 0 in there. And the momentum before is the mass of your head, times multiplied by the speed of your head, which was still up here in blue, still about 20 miles per hour. And that's going to equal the force multiplied by the time. From here, I'm going to do a little bit of algebra because I'm looking for the force. So a little algebra on this, and on the left side, I'm going to get negative mass times velocity divided by the time. And that'll give me the force. Now, it doesn't matter if I'm talking about the steering wheel or the airbag. The equation is going to be exactly the same because I'm still using impulse momentum theorem for each, and the momentum after your head hits both is going to be 0, and your momentum before is still going to be m times v. So everything is exactly the same. So I'm not going to redo the algebra again for the steering wheel and then again for the airbag. I just did it once, so now I'm just going to plug in my different numbers. So initially, my mass is 6 kilograms, and my velocity is 10 meters per second. And we'll solve for the steering wheel first, which means that we're dealing with a time for your head to stop of 0.1 seconds. And that will give me the force for the steering wheel. And when I plug all those numbers in, what I get is 600 newtons for the force of the steering wheel. Now, we said that initially your head was moving in the positive direction, so the force is going to be moving in the other way, which is why that's a negative number and not a positive number. That just means direction. So your head was initially moving positive, and now the force has to push backwards. And if you're interested, 600 newtons is roughly 134 pounds of force being exerted on your head in a pretty small space. That would definitely hurt. Okay, so now we'll solve for the airbag. What does the airbag do? It's the same equation. I still have my mass of 6 kilograms, and my speed is still 10 meters per second. And I divide by my time, which thanks to the airbag has been upped to half a second. Still a pretty short period of time. And we'll see what that does for us. So now we're looking for the force of the airbag. And when I multiply all that and divide, I get 120 newtons of force when I have my airbag. And what does that come out to be? 120 newtons of force is roughly 27 pounds of force. And that's actually also going to be spread over a much larger space because your head's going to hit the steering wheel, hit a small spot where the airbag is going to be spread out over your entire face, So you have much less damage, much better chance to survive. I would much rather, if I had to get hit with one of these, 27 pounds sounds a lot better than 134. So always make sure that, one, you fasten your seatbelt, but have airbags in your car. It's a good idea.